Myself, Dr. M. Vinayak, from the Department of Agricultural Engineering, working as assistant professor. So, last class we have discussed the what is the farm mechanization and classification of farm mission. So, mechanization nothing but application of engineering and technology to the farm level, increase the farmer productivity as well as decrease the input cost of the farmers. So, coming to the classification of farm mission, we have based on the field activities, we have classified the farm missions. So, tillage, sowing, intercultural operation, so intercultural operation, after that harvesting operation. So here so many operations are involved in the farm level. So based on the farm operations in the farm level, we have classified the farm machineries. So that is up to last classes. So today I am here to elaborate the classification of the materials as well as what type of material used in the different implements. So different heat treatment process. So summary, coming to the today's lecture. So today's lecture, introduction to material used in construction of the farm missions. Okay. So regarding this one, strength and durability service of the farm implement largely depend upon the quality of material used. So here strength and durability nothing but, so suppose we can take the tillage operation. So most of the tillage implements which was interact with the soil. Okay. So in that situation, most of the plows which was interact with the soil as well as plow the land below the earth surface up to 30 centimeter depth. Some of the tillage implement can plow the land up to 70 centimeter depth also. So suppose we have taken the two types of tillage implements. So two types of tillage implements. First one is a moldboard plow, that is MB, moldboard plow. Next one is a subsoiler. Okay. So this moldboard plow can plow the land. This one is the earth surface. This one is the earth surface. Moldboard plow can plow the land up to 30 centimeter depth, whereas subsoiler can plow the land up to 60 centimeter to almost 90 centimeter depth. Okay. So here this one is a moldboard share, this one is a subsoiler, soil interacting element. Okay. So here strength is very important. In case of moldboard plow, the operating depth of moldboard plow up to 30 centimeter only. In case of subsoiler, operating depth is 60 to 90 centimeter only. So in that situation, based on our requirement, so the strength of the implement, the strength of the tool will be increases. Okay, right? The 30 centimeter tool will strengthen little less compared to the 90 centimeter depth of ploughing. Okay. So now coming to the durability. So how much lifespan of the mission? So that is also one of the important element for the selection of material for construction of farm machinery. So next one is the implement parts component should be designed utilize the lowest cost of the material. Lowest cost of the material which can perform the satisfactorily and provide the adequate life. So for the construction of farm machinery, so the material cost should be minimum. That is the main thing the manufacturer need to consider before going to the design or before going to the fabrication of the farm machinery. So different types of material which was used for the construction of farm missions. So most of the tillage sowing equipments which was involved metals. So coming to the whereas intercultural as well as spraying equipments the material used as the plastic. Coming to the harvesting material also used as a metals. Most of the harvesters, movers can use it for the construction of the mission. So regarding to this classification of farm missions. So classification of classification of materials. So here the materials can be classified into the two types, metallic, non-metallic. Okay. So regarding the metallic, again they can classify into the ferrous metal, non-ferrous metal. So most of the farm machineries which was constructed by the ferrous metal only. Okay, so why? Because of the more strengthened was required to the farm machineries. The compared to the non-ferrous metal, ferrous metal was more strengthened. So coming to the ferrous metal, again they need to they can classify into the two types, iron and steel. Coming to the non-ferrous metal, so again they can classify copper, zinc, lead, tin, aluminum, brass, bronze, white metal or solder. Next one is a non-metallic wood, rubber, leather, plastic, fiberglass and Teflon. So here I will explain the what type of material can use in what type of implement. So first one is a cast iron and steel. Most of the tillage implements, stowing as well as harvesting implements used in these two type of metals, cast iron and steel. Coming to the non-ferrous metal, for the construction of seed hoppers as well as lightweight material, intercultural operations, some sprayers also, lightweight boom sprayers also can go for the non-ferrous metals. Okay, so next one is a non-metallic materials, which was coming to the rubber and plastic. Most of the seed drill metering mechanism which was developed by these metals only, rubber some cases as well as plastic some cases. Okay, so some other type of machineries also involve the wooden also. So this one is a brief introduction about the materials construction for farm missions. So in detail we can explain what type of implement, what type of materials was used for the construction of farm mission. So these are the two types of implements. So first one is a moldboard plow, this one is a moldboard plow, this one is a cultivator. Okay, moldboard plow and cultivator. So in detail we can regarding the parts of the moldboard plow, in detail we can explain the upcoming lectures. So here I briefly explain the what are the material used for the construction of the moldboard plow. So this one is a frame, this entire section called as a frame. So this entire section called as a moldboard. So some other parts also there, I will explain the later. So regarding the frame, most of the moldboard plow manufacturer, they can construct the frame with the mild steel. Next one is the soft center steel for the construction of moldboard. So this one is a frame, this one is a moldboard. This can be constructed by the soft center steel. So this one called as a share. Share can constructed with the mild steel. So this one is a landslide. Landslide constructed with the high carbon steel. So here we can observe most of the soil interacting tools which was made by the steel or high carbon steel, normal carbon steel or mild carbon steel. So most of the soil interacting tool which was used with the steel only. Why? Because of the steel cannot resist corrode with easily, cannot corrode easily. Why? Because of the nomenclature of the steel, it cannot interact with the, cannot what you call, cannot collaborate with the any other type of materials. So that's why most of the soil interacting tools which was made by the steel only. Okay, like high carbon steel, mild steel, soft center steel, like most of the soil interacting tool made up of steel only. Okay, so that's why here this moldboard also soil interact with the soil, this share also interact with the soil, this landslide also interact with the soil. That's why this entire components was involved with the steel only. Okay, so next coming to the cultivator. This one called as a frame, this one tines. This tines was interact with the soil. So that's why it was made up of high carbon steel. So this one is a mild steel. Okay, so compared to the high carbon steel, mild steel was very less in weight less in strength also. So that's why, so for the frame, any other light type of works which was made up of mild steel, any other heavy duty works, heavy metals can be made up of high carbon steel. So up to now we have seen the two types of tillage implement. Interact with the two types of tillage implement. What are the material used for the construction of two types of tillage implement? So after tillage implement, next go for the sowing operation. So here we have seen the seed cum fertilizer drill. So different components are there here. So in detail components with the function we can covered in unit 2. So here briefly I explain the what type of component here and what type of material used for the construction of that component. Okay. So first one is this one called as a hopper. So this hopper contain the seed as well as fertilizer. So this hopper made up of mild steel, galvanized iron or fiber glass. Okay. So this the hopper should be in less in weight. That's why here we are used the non-ferrous metal. So that is different non-ferrous metals was classified in previous slides. So among this we have selected the mild steel, galvanized iron sheet and fiberglass. Okay. So whenever the construction of the seed hopper, we need to go for the minimum weight of the material. Okay. So next one is these are the seed conveyor tubes. Okay. So simply here we are pouring the seed here in seed hopper. This seed hopper can convey the seed from here to this section using this seed conveyor hopper. Okay. So these are the seed conveyor hopper. So this seed conveyor hopper was made up of rubber or PVC plastic. Okay. This conveyor hopper can made up of rubber or plastic material. So coming to this section. So this one is a furrow opener. So this furrow opener which was interact with the again this furrow opener which was interact with the soil. So that's why this interaction tool was made up of high carbon steel. Okay. So previously I explained most of the soil interacting tool which was made up of the steel only. Okay. Next one is a cast iron. So these are the what we call this component called as a seed boat. So this component made up of cast iron. So this one is the intermediate section between the furrow opener and seed conveying tube. Okay. So this seed conveying tube can be interact with the seed boat. So next one is a mild steel. So the entire frame was made up of mild steel. This one is a frame. Okay. So here some other components are there. Seed metering mechanism which was made up of mild steel, aluminum, brass. Some of the seed metering mechanism which was made up of plastic also. Okay, vertical edge cell seed metering mechanism is there. So it is made up of the plastic only. Okay, next one, mild steel and cast iron. So this one is a covering device. The entire seed cum fertilizer or seed drill can covered with this metal sheet. Okay, compared to the galvanized iron, this was very less in weight. That's why for covering purpose they are used the mild steel or cast iron. So this is a complete material which was used in the seed cum fertilizer drill. Okay. So here some materials are there and carbon percentage are there. Carbon percentage was mentioned. So here for increase the carbon percentage in the material, so definitely it can increase the strength of the material. Okay. So first one is pig iron, the carbon percentage 3 to 4, which was followed by the wrought iron 0.02 to 0.3. So same like coming to the lowest carbon percentage was observed wrought iron. So highest carbon percentage was used in pig iron. So based on the manufacturer or designer requirement, they can select the material. So what type of material we need to use. Okay. So if the material was interact with the soil, we can go for the high percentage of carbon percentage of material we are used. If they go for the lightweight material, we can go for the wrought iron. Okay. So after finishing the sowing operation, next go for the intercultural operation now. So here small tools are there for the removing of weed from the land. So here some small tools are used for the intercultural purpose. So this one is a hand hoe. So here three blades are there, small blades. They can remove the weeds from the field in between the rows as well as in between the plants. So it is made up of the handle which was made up of plastic. So these three blades made up of mild steel. So again here the mild steel was involved. Why? Because of this entire tool interact with the soil as well as water. For that purpose, most of the soil interacting tool was made up of the mild steel only. So next one is a wood. This is also another scraper for the removing of weeds. So it is made up of the wood or plastic of the handle made up of wood or plastic. Again the blade made up of carbon steel or alloy steel. So the percentage of carbon is 0.05 to 0.8. Manganese, some mixture of components are there. So next one is this one called as a wheel hoe. Okay. So here it is consist of a frame. This one frame. This one is a handle. This one called handle. This one is a frame. This one is a wheel. This one is a. These are the tools for the removing of weeds. Okay. Tools are blades and called as a blade also. Okay. So the handle sometimes made up of the wood as well as mild steel. Both handle and frame which was made up of the wood or mild steel. So next one is a wheel. So by rotating the wheel into this direction, this blade can move forward and reverse direction. Forward and reverse direction. Okay, suppose one weed is there, this blade can move forward and reverse direction. In this situation, the weeds can remove from here and throw on the back side of the moving direction. Okay, this one is a wheel which was made up of the mild steel cast iron. So the soil engaging tool or soil interacting tool made up of the mild steel, the carbon percentage ranges from 0.5 to 0.6. Okay. So we are not the metallurgical engineers, we are the agriculture engineers. So we need to know the basic terms or basic functionality related to the materials. So for that purpose, some small chapters are there in the formation and equipment lecture. So before next going to the introduction to heat treatment. Okay, right. Regarding the heat treatment involve control the heating and cooling of the material. Okay. So without going to the heat treatment, the material cannot be sustained. Okay. So suppose I will differentiate the before going to the heat treatment and after going to the heat treatment with the small diagram. So this one is a after before going to the heat treatment process. This one is a after heat treatment process. So here I am taking the one small metal, here also I am taking the small metal. Okay. So the distribution of molecule in the before going to the heat treatment, the distribution of molecule in small metal before going to the heat treatment, it is likewise. Okay. the distribution of molecule before going to the heat treatment, the molecule was distributed like this. Okay. So after completion of heat treatment hardening process, the molecule can be like this. Okay. So here we can clearly see the distance between the molecule to molecule is more before going to the heat treatment process. So the distance between the molecule to molecule is very less after completion of the heat treatment process. Okay. So if decrease the gap between the two molecule, what will be happen? The strength of the particular material will be increases. Okay. So for that purpose, most of the manufacturer designer of the farm machineries, they definitely go for the heat treatment process. Why? Because of the for increasing the strength of the material. Okay. So here we clearly we can see here the distance between the two molecules is very more compared to the after completion of the heat treatment process. Okay. So heat treatment process nothing but control the heating and cooling of the material. Okay. Next one is a why we are going to the heat treatment process. Okay. So for increase the hardness of the material, for increase the strength in the material, toughness and wear resistance, critical for components like plow, shear, tines, shovels and shaft. So these are the tools which are mostly interact with the soil. These are the primary and secondary tillage implements. So we don't know the how much amount of force act on the tillage implement. For that purpose, we need to strengthen the our material which was interact with the soil. For that purpose, we are go for the heat treatment process basically. Okay, for increase the hardness, strengthness of the material. So in detail here we can see the some of the heat treatment methods. So first one is the hardening. The metal is heated at the temperature of 1094 degrees and cooled suddenly by quenching into the water or oil. So initially the material need to heat at the temperature of 1094 degrees at a certain time. So after that simply the material pour into the water or oil, that is a hardening process. Next one is the annealing process. The metal is heated at the temperature of 840 to 955 degrees Celsius and allowed to maintain maximum temperature for one to several hours according to size of the metal, then allowed to cool slowly. So in hardening process, after completion of after getting the temperature of 1094 degrees Celsius, simply we can take the material and pour into the oil or water. In annealing process, after getting the temperature 840 to 955 degrees Celsius, so the material itself allowed to cooling. You did not pushing the cooling to the oil or water. So simply the material itself should be cool slowly. Okay. Next one is the tempering. Heating of hardened metal about 500 degrees Celsius and cooled by the pinching in liquid. Okay. So both hardening and tempering is same, but the temperature vary. Okay. So for hardening purpose we can maintain the higher temperature. For tempering purpose, you can go for the lowest temperature, that is 500 degrees Celsius. Next one is the case hardening. The process of introducing the additional carbon into outer layer of the steel pieces. Okay, so that is called as a case hardening method. Okay, suppose this one is a steel material. Okay, steel material. We need to add the some amount of carbon particle into the outer layer of the steel material. So this one is a steel. The outer layer of the steel, we need to apply the liquid form of the carbon. Okay, the outer layer only carbon material, inside of the carbon it is a steel. Okay, So here also for the increase the hardness of the material, we can simply add the carbon particle to particular steel material. Okay. So here we can see, we can show the hardening, annealing, tempering, case hardening. So where for hardening material, increase the hardness, tensile strength and brittleness of the material, reduce the material ductility. So coming to the annealing, refine the coarseness of the grains, remove the strain and increase the tensile strength of the material. So here increase the temperature from annealing to hardening, to increase the hardness. So here simply remove the coarseness of the grains from the material. So here grains nothing but molecules in particular material. So suppose this one is a material, these are the, here they are mentioned the grains. Here grains nothing but molecule of the material. So next one is the tempering, reduce the brittleness and increase the toughness and ductility of material. And last one is the case hardening, increase the wear resistance, corrosion resistance to the scaling of surface layer of the material. Okay, if the steel coated with the carbon, that is called as a case hardening. No, so in case hardening method, increase the wear resistance, so it can decrease the wearing resistance. Why? Because of the outer layer of the material which was coated by the carbon, so that's why it can increase the wear resistance. Here the carbon cannot be interact with the soil as well as water, so that's why the wear resistance will be increases. So aluminum also, aluminum, carbon, steel, they cannot easily resistance or corrosion with the easily not corrodable. Why? Because of the, they have a own property of own property. Okay, so aluminum for the most of the electrical department they can use for the aluminum material. Why? Because of the, it cannot be corrosion resistive as well as lightweight. Most of the electrical weights they can made up of the aluminum. Okay, so next one is a benefits of heat treatment. Okay, so up to now we have seen the introduction to heat treatment process as well as different methods of heat treatment process, as well as we have explained the what type of material used for the different forming implements. So here you can go for the benefits of heat treatment process. It can increase the mechanical property of metals. Okay, mechanical properties nothing but, before suppose we can take the one shovel. So this shovel can sustain the load of 100 kg per centimeter square. So this one is a one type, this one is a second type shovel. This one called as a shovel which was interact with the soil. So before going to the heat treatment process, it can sustain the 100 kg of load. Okay, after going to the heat treatment process, it can sustain 150 to 200 kg per centimeter square of load. So why? Because of the, here after getting the heat treatment process, the material can enhance the property. Okay, so next one is a improve the machinability, customize properties, relieve the stresses, increase the corrosion resistive. So last slide we have explained this only. Okay, corrosion resistive also it can get the by using the heat treatment process. Relieve stresses also we can get the heat treatment process. So these are the important terms related to heat treatment, benefits of heat treatment. So next one is a application in farm machinery. So where we can use, in previous slides we have seen the different tillage implements, sowing implement and intercultural operations. So here particularly where it can use, so plough blades we can use the heat treatment process where it can used in the farm missions. Okay, we need to go for the construction of tillage implement. Plowing blades are very important. Why? Because of the most of the blades was interact with the soil. So that's why purpose, before going to the construction of blades, need go for the metal should be go for the heat treatment process. So these plow blades should be heat treated. So next one is the cultivated tines. So this is also hardened and tempered. Coming to the rotavator. So this rotavator, both primary and secondary tillage implement. So this list of implement we can discuss in unit 2. Can require the hardness and sharpness of the resistance. The result in longer tool life and low maintenance. So whatever the implement used for the construction of farm mission, so it should be in a long life as well as low maintenance. Why? Because the farmers cannot do the maintain the tillage implement. Why? They don't know the how to maintain. So for that purpose, the material should be long life and maintenance should be less. So from this lecture, the student can summarize the what are the introduction to materials used for the construction of farm missions. So different types of implements was seen, what type of material used for the construction of farm mission. So coming to the introduction to heat treatment process. Regarding the heat treatment process, some important heat treatment methods was explained. So what are the advantages regarding the heat treatment process also we can learn. So last and final but one, where the heat treatment process can involve for the construction of the farm machinery. Thank you.